So in this video, we're going to talk about how to use quadratic functions to model data. So suppose the height of a diver is modeled by h of t equals negative 16t squared plus 10t plus 6, where t is the time in seconds. Solving the equation h of t equals 0 will actually tell you when the diver will hit the surface of the pool. So remember, that means that we can just plug in 0 for h of t and we can solve this equation, right? So we'd have 0 equals negative 16t squared plus 10t plus 6. Okay, and so we can solve this. Notice that these three terms all have a GCF, so we can actually factor out a 2 from each term. So that leaves us with negative 8t squared plus 5t plus 3. Right, so we can divide both sides by 2. So we can simplify that equation, and so we'll have 0 equals negative 8t squared plus 5t plus 3. So then we can use the quadratic formula. This will be a, this will be b, and this will be c. So we have negative b, so negative 5, plus or minus the square root of 5 squared, which is 25, minus 4 times negative 8 times c, which is 3, all divided by 2 times negative 8, right? So we'll have negative 5 plus or minus the square root of, let's do that, everything under the radical in our calculator. So we have 25 minus 4 times a, which is negative 8, times c, which is 3. And so that gives us negative 5 plus or minus 121 over negative 16. Okay, so if we solve this, the square root of 121 is 11. So we have negative 5 plus or minus 11 over negative 16, which now gives us two solutions, right? So that gives us negative 5 plus 11 over negative 16. And it also gives us negative 5 minus 11 over negative 16. Negative 5 plus 11 is 6, and 6 divided by negative 16 is negative 0.375. So remember, in this case, t equals time. So negative 0.375 seconds doesn't really make sense because we can't have negative time. So that's our extraneous solution. And then when we have negative 5 minus 11 divided by negative 16, that gives us an answer of 1. Okay, so that's a reasonable answer. So 1 second after he starts diving, we predict he will hit the surface of the pool. Also, based on this equation, we can tell his maximum height, okay? Because what the diver is going to do is, like, he kind of jumps up, and then he's going to go up, and then he's going to go down, and he's going to hit the pool, okay? So this maximum height of his jump, we can figure out using this x equals negative b over 2a, right? That's going to tell us the x value at which the maximum height occurs. So remember, in this case, this was b, and this was a. So if we have x equals negative b over 2a, we have negative 10 over 2 times negative 16. So that gives us negative 10 over negative 32. So if we do that on our calculator, we have negative 10 divided by negative 32, and that gives us 0.3125. Okay, so at x equals 0.3125, he will have a maximum height. You can also figure this out by typing this equation into Desmos. And if you do that, you can see that, that 0.3125, here it rounded to 0.313, but you can see that's where he reaches the maximum height. And then also after 1 second, you will see that he reaches that value of 0, which is when the diver hits the pool. Okay, so when we write quadratic regressions, remember you have a choice. You can use Desmos or you can use your calculator. Here are the instructions for both methods. You can just pick your favorite and choose that to write regressions. Okay, so suppose we're solving this problem. Isaac plays basketball and wants to improve his percentage of basketballs made from the free throw line. He took videos and wants to analyze the path of the throws that made it in the basket to improve his throwing technique. Okay, so this is going to be a parabola because he's going to throw the ball and it's going to go like this and then it's going to fall in the basket. Okay, so that's why it's modeled by a quadratic equation. From the videos, he was able to collect the following data of the height of the ball for each second after the throw. Use the data to create a quadratic function that represents Isaac's best throws. And then we're going to use the equation to determine the max height of the free throw and the time at which it occurs. So first I'm going to show you how to do this on Desmos. Like I said, you can choose your favorite method. You don't have to use Desmos all the time, or you don't have to use a TI all the time, whatever makes sense for you. So whenever we're starting in Desmos, I'm just going to clear everything I already have. And then I'm going to click plus and then choose the table. And then I'm going to go ahead and enter these values into X1 and Y1. Okay, so remember this is going to be X1 and this is going to be Y1. So I'm going to pause the video while I do that. Okay, so now I have all these values entered here from my table. So I'm going to go ahead and tell Desmos to figure out a quadratic regression. So I say Y1 is approximately AX1 squared, and then plus bx1, and then plus c. Okay, so down here in parameters, it's going to give me the values of a, b, and c. I need to write my equation. So let's go ahead and do that. So we have y equals negative 88.114 x squared plus 38.53x, and then our c value is plus 8.775. Okay, so that's how you do it with Desmos. If you prefer, you can do this on your TI calculator. So remember, you're going to go to Stat and then hit Enter on Edit. Go up and then clear each column. And I'm going to pause the video here while I go ahead and enter these values into my table. Okay, so now that we have all these values entered, we are going to figure out a quadratic regression. So you go to Stat, arrow to calculate, and then choose option 5, which is quadratic regression. And then keep hitting enter until we get our values of a, b, and c. So once again, we can write the equation. That is going to be y equals negative 88.114x squared plus 38.53x. And then we have plus 8.775. Okay, so now that we have this equation, we are going to use it to determine the maximum height of a free throw and the time at which it occurs. Okay, so let's think about the equation. We have y equals negative 88.114x squared plus 38.53x plus 8.775. Okay, so remember, this is A, this is B, and this is C. Okay, the max height, remember the x coordinate is going to be negative b over 2a. So if we get those values from our equation, we have negative 38.53 divided by 2 times negative 88.114. Okay, so that x value is approximately going to be, let's figure that out from our calculator. We have negative 38.53 divided by, and then we have 2 times negative 88.114. So let's go ahead and hit enter, and that tells us that x approximately is 0.219. Okay, so that is going to be the time in seconds at which the best free throw occurs, right? The maximum height is going to occur then. But it also wants us to figure out what is that maximum height, okay? So to figure out that maximum height, I need to plug in this 0.219 into my equation and solve for y. So I have negative 88.114 times 0.219 squared plus 38.53 times 0.219, and then plus 8.775. Okay, so once again, it's a bunch of number crunching, so I'm going to do it on my calculator. Negative 88.114 times 0.219 squared, and then plus 38.53 times 0.219, and then plus 8.775. Okay, so when I do that, it gives me a value. So that's going to be about 13, right? And then my units are feet. So we're going to have a max of 13 feet at 0.219 seconds. Okay, so now you can go ahead and pause the video and try this example on your own. Okay, so this is one of those examples where we have to create our own table because it just gives us a list of coordinates. So I just put all the x values into this column and all the y values into this column. I prefer to do this in Desmos. Like I said, you can use your TI calculator if you would rather do that. So I created my XY table, and then I typed in ax1 squared plus bx1 plus c. And in parameters, it gives me the a, b, and c values, right? So my equation is going to be y equals 2x squared plus 3x minus 2. So it wants me to estimate the value at x equals 5. So I'm going to go to this function. I'm going to plug in 5. So I have 2 times 5 squared plus 3 times 5 minus 2. Okay, so I'm going to use my calculator now to figure that out. So I have 2 times 5 squared plus 3 times 5 and then minus 2. Okay, so when I go ahead and hit enter, it gives me y equals 63. So that is the value of this function at x equals 5. So remember that using your calculator, you can model data using quadratic regressions, and you can use these equations to predict future values.